Then I'm Johnny Mariéthoz. Just a few words. In my previous life, I did machine learning at IDIAP. I didn't know that there was a presentation about a company, but I leave IDIAP before the creation of this company. Then now, in fact, I work for a network of library in Switzerland, and I spend now 7 years as an Invenio developer. I'm also bass and double bass player, and sometimes I take pictures with very strange old analog camera. Rero is the library network of Western Switzerland. But we have several kind of libraries, especially academic libraries, heritage libraries, public libraries, school libraries, and so on. Plenty of students. We are present in 5 cantons in Switzerland. We have a large amount of patrons, readers. We have 3 academic universities, 1 University of Applied Science, and for all these guys, we are 19 people at Martineau that try to create software, to create services for these libraries. And today I will talk about the use of Elasticsearch in a context of a very common problem that we have, or service that we want to build on the top of it. And the idea is the following. Probably we want to store some objects. It can be JSON, it can be metadata, it can be also files. But basically, I want to store this object in a persistent storage. And I want to address this object using a persistent identifier. Then the ideas of persistent identifier is to assign an identifier to an object, and this identifier is not supposed to change over the whole life of this object. That's the idea. And the PID is also usually public. That means it can refer to an object for example, from other websites. I probably need some schema. That means I want to describe my data. I want to validate the data that I entered into the system that follow a certain framework or schema. And I want to put this data in a certain engine because I want to search in this plenty of objects. This is usually the data part of my application. And I probably need also a web server. Then I want to access the data through the REST API, for example, to provide external services. But using, for example, JavaScript frontend, I can provide HTML web page from the REST API to provide GUI for the end user, but also some specific HTML code for search engine. I can also perhaps attach files to the metadata. This is exactly the case that you have. That means you have also videos or audio files or pictures or anything else. And you want to link with the metadata. And these files you probably want to be indexed by Google and also downloadable and by the user, or you can also provide some preview functionalities. And perhaps you want to export your data in other formats. Then this is the typical web application. Between the two, usually I need also some access restriction for some data. Then usually what I need is data management. It would be cool if I can have something it's able to do versioning, validation. I have a persistent identifier management if it's possible. I need a search engine. In that case, Elasticsearch, right management. If it's possible, I need templates for HTML, URL management for routing, REST API generation, format conversion migration, and so on. From the development point of view, it would be cool if I can have like a framework or libraries, because I don't want to patch the code or existing things. In fact, I want to reuse all the blocks for any application. I want also that facilities to create new features, new modules. You know that managing assets can be quite painful. It would be great to have a tool for that. Asynchronous task management, for example, for indexing large collection of data or to sending plenty of emails. Unit testing and logging, translations, front-end and back-end, and many more. Then what I want to present to you today is Invenio. Then Invenio can be an answer to this problems. Then historically, Invenio has been developed by CERN for their own needs, but it's very, very old project because it started in 2002. It was open source from the start. It was developed for high energy physics. Then this is actually the software that used to provide document server for the CERN. It also used this Invenio for their own library system, and there are plenty of other projects, because in fact the CERN use Invenio now for plenty of European projects and other applications. At the beginning, it was a front-end application using Python, MySQL, and about nothing else. They had their own search engine and their own templating system and so on. They have a second version. It was a transition version to the complete new rewritten version 3 version, which is not now only focused on digital library or library system, but it's really generic. Then the idea is to have plenty of generic base block to deal with this kind of deal. Then the use technology is basically a set of Python module. And it includes module interaction mechanism. This is probably the most valuable, the most value of the Invenio actually. Then we can see it as a framework around state-of-the-art technologies. But if you don't know this technology, of course, the learning can be a bit steep. Then it used, based on Python, it used Flask, which is the web framework for Python. It used Celery, which is Python Python module around RabbitMQ, and it's for queue system. The search engine, you can choose either your SQL database. Usually SQLite is used for testing only, but you can choose MySQL or Postgre. And the front-end technology is based on AngularJS, Twitter Bootstrap, NPM. It uses Jinja 2, which is the templates for Flask, and Redis for cache. The Docker. Docker is the Docker is now a container system in order to. You can see Docker as virtualization, basically. Okay, because in fact we use Docker as for development, and there are some instances that are in production under Docker, but also they provide Docker images for Invenio to test it and for development. And what about the Elasticsearch integration? Then the difference between the new version and the last one is that SQL is not used anymore for HTTP requests. It's all the data are served directly from Elasticsearch, and SQL is there only for persistent data. The data model is based on JSON. It uses JSON schema. I don't know if you know. Who knows JSON schema? It's a bit okay. You can see JSON schema like a DTD for JSON, because the idea is just to validate, to describe your data. I will give you an example. And of course, you have to write the mapping for Elasticsearch. It is also possible to have a configuration. Imagine that in your project you have to deal with different kind of objects. For example, I don't know, books, but you want also cars and I don't know, guitars and so on. In fact, it is possible to have configuration for each kind of object. And in that case, you can have a REST API specifically for each kind of object.
So you store JSON inside of SQL database?
Exactly. Yeah, because now, in fact, PostgreSQL and I think MySQL have a specific type for columns, which is JSON. That now it's possible to.
You can index individual fields.
You can do that, but this is not the aim. The aim is if you want to search something, you have to use Elasticsearch. That's the idea.
You still need SQL
Mainly for like the persistence of the data and also for the versioning, because you can keep all the version, all the modified version of the data over the time.
But you can probably do it the same in NoSQL.
Okay, but not in Elasticsearch, as I know. Yeah.
You mean you can do it like automatically? That the database takes care of it? Or
Yes, exactly.
okay.
Exactly. In fact,
Elasticsearch probably you can do it, but you will need to implement some business logic to do it.
I think so. Yeah, but yeah. In fact, in Python, you have SQL Alchemy, which is a framework around SQL engine, and it's possible to add automatically this behavior on that. It uses the official Elasticsearch Python package. It provides also command line interface in order to create index, push mapping, and all this kind of stuff. Then, now, imagine that I have data like this. This is an album of music. Then I can have a name of the album, artist, genre, mime types for the attached files, performers, and the track lists, the years. Then the first things that I have to do is to write the schema. Then the schema is also a JSON that describes this structure. Then I didn't put all the fields there, but only some. But here I have the title of the schema, that I say that this schema is describing a music album. And the data that I want to describe is the type of object. The properties here, I can say that the album is a string, it's not an integer, and I can fix a minimum length. For example, for the mime types, okay, it's a string, 7 characters. I can specify a pattern. This is a regular expression to validate the contents of the mime here, or I can also list the all possible value of this field. I can specify here that for the validation that this document should contain at least the name of the album and the year of the album. And I can say that I don't want to have additional properties. That means other kind of properties is not allowed. If I write here Toto is something, is equal to something, the validation will fail.
This file, where is it coming from?
This?
No, the JSON file.
It's your data.
But I mean, it's something that says this library guys input manually into the form and it's sent on the server, and that's when you do the validation, or they
Yep.
can ship some files like JSON files.
It's up to you.
You can do both.
Yeah, you can do both.
Okay, then that's when you validate.
Yeah. In fact, at each time, we will see later, but it's possible to attach the schema to the data. That means here I can add a specific field here to say, okay, this is the schema to validate this data. That means after that, at each modification of the data, I can perform the validation. Then the mapping, if you already play a little bit with Elasticsearch, you know that. But again, this is the same JSON file. And I have to write something like this. For example, I can disable the automatic type detection. And I can say, okay, this is the definition of the analyzer for the album properties of this. This is a string. And I will, for example, here I say that all my album name are in English, then I can specify here the analyzer. And I can, for example, copy these properties and new properties for sorting. I can do the same, for example, for artist here in order to create facets or aggregators for that. This is exactly the same JSON that you have to put in your Elasticsearch cluster. There are no difference. Then how we use the schema and the mapping. Then usually we put this file in a specific directory of your module here. And it should be included in your data. Then there are some facilities to do that. But the idea is to attach this name or this URI to the data in order that at each time that I modify the record, I can redo the validation. The JSON schema is also the documentation for humans because it's possible to add description and titles for each properties of the object. And the name is really important here. This is about the magic trick of Invenio. The idea is that when a new data arrived, in fact, and I want to index it, it will go into the data, check this name, and infer the index name and the document type from the name of the schema. Then the idea is that, okay, it will index the current data in this index and in that document type. The mapping is about, it's about the same, except that we can change the name of the directory. And then we can put the mapping using the command line interface. And again, the name is important because, in fact, for the mapping, it will create the index and put the mapping for this document type given the name of the mapping. And also, what is quite cool is that if you have several here, mapping file here, in fact, it puts all this in the same, for the same alias. Then it's possible to have more than one document type, even if it will disappear soon, but then what I have to do, I have a specific configuration here in Python. The idea is here I can describe the facets. For example, here I want to add to my REST API a new facet, the genre. This is just a term facet to aggregators, and I take the field genre. I can give a usual option for Elasticsearch for that. I can have another kind of facets here. For example, instead of terms, I can have dates, histogram, for example. And here I can also configure the filters. Then what's happened when I click to the term in the interface when I want to select or focus the search result on a certain fields. I have to also configure the sorting. Then the idea here is that I can specify two ways to sort the result, best match and the most recent, for example. For the most recent, then this is the creation of the date where we put, in fact, the data in the system. And here I can specify that when I have a query, I want a best match sorting. When I don't have a query, I will sort by the most recent document. And finally, this is the REST configuration. Then here, I can specify for a certain kind of object. Here's a record ID, but it can be, for example, books or albums, ID, or I don't know. You can specify a specific Python class to create the search query. I can specify the index, the list of document type. If it's not, it's all. Here I can specify some transformation to transform the original, the result of the Elasticsearch in a, for example, specific JSON. This can be used also for content negotiation. Here I can have, for example, application XML and provide some serializer to produce XML here. Here I can specify a Python function in order to create the search object. The idea is to take the previous facet configuration and add to the query the list of the facet and the filters. Then it's possible to configure it, but you have one by default. And here I can specify the URLs that I have to use for the REST API. Here I can put, for example, albums or music, so up to you. Then I can show you now, because it was a bit technical, that at the beginning, this I can have just a web search interface. For the moment, I have my data already loaded in the SQL, but nothing in Elasticsearch. Then if I check it, here, this is the URL of my Elasticsearch server, and I see that I don't have any aliases, nor neither results, but I have here. This is an example of the data. It's not in JSON, it's in HTML, but the data is in the database. Now, the first things that I have to do is to create the index. And now I can say, okay, index, no, it's not the right one. I can say, okay, I want to initialize the index and initialize the indexing queue, because we need an indexing queue for asynchronous stuff. Then the only things that I did is just to create the mapping, the JSON schema, put the data in the JSON in the system, and the configuration. That's it. I didn't do anything else. When I did that, after this command, in fact, when I go to the mapping, I see that it has created the Elasticsearch index, put the mapping in that, create a new alias, record on this name, on this index. This is an alias. And for the moment, I don't have any results because I didn't index yet the stuff. It is also possible to access to the JSON schema here, because the schema is supposed to be public and accessible through the web. And now I will reindex the data. Then the first is just to put index reindex is putting all the data in the queue, and the run is indexing the queue. Then when I go first to the result here, I can see that at each time that I refresh the page, we can see appearing the results here until it ends. Okay, that's it. What is nice is that just with this configuration, I have a REST API here. For example, here you can see API/record, and this is the PID of the record, and you can see here the JSON. And the REST API, I have also, for example, a search. Here I added a new query here, and I search miles. And here I can see that for the moment the aggregation are empty. And here I have the common Elasticsearch results. And just for demo, just for the demo, here in my configuration file, I just uncommented the configuration of the facets. And when I go back, to the search, you can see appearing here the facets. That means just by adding few lines of code, in fact, you can have faceting facilities. And the conclusion is very generic and very flexible. You have a great open source communities around of Invenio, and it's managed by the CERN. Yeah.
So just a question, did it auto-generate your REST API?
Sorry?
Did it auto-generate the REST APIs from the definition of your config file?
How?
Did it? So what you put in your config file, like the root,
Yep.
it auto-generated?
Then, okay, then basically, if you have your JSON schema and your mapping in the right directory, and you write this 3 piece of configuration, that means the record REST endpoint, the search and the facets, you have the REST API ready. Not too difficult. And you can see that here at each time it is possible to create more than one. That means you can do that for different kind of object. Then it's quite easy to develop new prototypes application. Demonstrate time due to the learning curve. And it is at the center of our future developments. Then actually we have two main projects then we have planned. They are not really, we are not working yet on it. They need to be accepted. But for the moment, the idea is to create a new open access research publication repository. That means we have the mission to collect all the research papers from the Switch researcher and create a repository for that. And actually, we want to replace our commercial product system for the libraries by our own development in open source based on Invenio, which is a quite big project, probably 3 or more years project. And we hope that we can have more than that. And some references. And thank you for your attention.